Good morning to everybody. All right, we're going to talk about related rates. So, there's nobody in robotics in here, correct? So, my wife and I took Rosie to Quarry Park. Do you guys know where Quarry Park is? Yeah. It's kind of a neat place. Like, I think, if you ever saw, the parking lots were full yesterday and the day before yesterday. And it's because those are the last 2 days. It'll be nice, and then winter will be like here, which is fun. You can go out there do. But on the way back, I said, my wife's name is Julie. I said, take a look. There's an advertisement for robotic surgery from the St. Cloud Surgical Center. Yeah, that's kind of cool. And so, they don't have a human hand, but I suppose you're controlling. A friend of mine is a cardiologist at St. Cloud, and he said the surgeons now are better than the older surgeons because most of them are game players. And everything's so technical, like playing with, I don't play video games. I got confused with Pong, and then I stopped after that, okay? And but you have the idea that you have a joystick and you're able to do these fine motor skills is a big advantage when you're working on the brain or on the heart and so on. But they have robots that will do that, and you monitor those. Okay, so I'm going to draw, and I don't know if Karsh taught you this, but that's like a 3D coordinate plane. Does that make sense to everybody? You don't need to write this down. This is just, and so let's say that point is the tip of whatever is the tip of the knife, okay, or whatever it is that's entering the human body. Does that make sense? It will have a location, an X, a Y, and a Z location. Okay, and let for a moment, let me say that this is the x-axis, this is a y-axis, and I'm on this plane. In other words, Z is equal to 0. Does that make sense? Okay, and let's say this is moving in this direction. So for me, it's like I came, I'm right here and it's moving across my chest. Like maybe it's cutting me open. Okay, and it hasn't penetrated, the knife so sharp that it just starts to separate the skin. Does that kind of make sense? All right. So this point or that tip would have a rate of speed, correct? And it's moving horizontally. So I now, since it has a rate of speed, I got to turn this down because I'm getting feedback. That X is moving at a certain rate. So I've introduced a new variable called time. And the variable I'm going to use for time is t. So dx dt would be, hi, how are you? Okay. I have stuff to give you. This is something, and Ethan will tell you everything about these. Okay. And this is something, and those are assignments. If it's white, it's not supposed to be an assignment. These are notes, and this is where I started. And I haven't started them yet. I'm just telling a story. Okay. So dx dt would be the rate that the point is moving in the x direction. Would that make sense? If I'm going like this? And so what would dy dt be? Alex, what do you believe?
The rate that the point is moving in the y direction.
The rate that the point is moving in the y direction. Would you agree? Do you have an idea? If the tip of our surgical tool just makes that horizontal slice, do you have an idea of what that rate, what dy dt would be?
0.
Why?
Because it's not moving up or down.
It's not moving up or down. And what about dz dt? Aaron, what do you think that represents?
The rate that the point is moving in the z direction.
Yeah, the z direction, which for me, in my picture, is backwards and forwards, correct? So if I bring it away from the human body, that would be negative. And if I would plunge it into the human body, that would be positive. Does that kind of make sense? What do you think its numerical value is right now if I just do that horizontal slice? 0. Would everybody agree with that? All right, so now let me draw you another picture. And I'm still going to stay on this plane. So in other words, dz dt is equal to 0. But I would have something that looks like this. A cut that looks like that. Now I still don't know how fast y is changing or how fast that x is changing, but what can I say about their rates when I compare the two? And what I'm saying is, are they equal? Would one be faster than the other one? What do you think? So my options are A, dy dt equals dx dt, B, dy dt is less than dx dt, or C, dy dt is greater than dx dt. What do you think? You think it's one that they're equal?
Yeah, I think they're all equal.
Okay. What if I had a slice like this? Let's say it looks like that. Notice I use red. And I'm still on that plane. Bryn.
Wouldn't that, the red one, be equal to each other?
Yeah, why would you say that?
Because it would be like 1 over 1 if you do rise.
Yeah, both the x value and the y value are equal, correct? Right? So in here, I could write that y equals x, right? That's the equation of that line. And since time is the variable, I can do implicit differentiation, and this becomes dy dt, and this becomes dx dt. You notice how before we had dx over dx when we did implicit? But now, because we're computing with how fast the x is moving, how fast the point is moving in the x direction over time, this is how fast the y component is moving over time. If I take the derivative of that, I would get 1 times dy dt. I would get 1 here and get dx dt. This is what it would look like if they're equal. So what do we think here? Yeah. Yeah, why do you think dy dt is greater than dx dt?
Because dy dt is, to me, it looks like it's increasing at a faster
Right, it looks like I went up more than I went across, correct? So in other words, if I drew kind of a triangle, here's my x distance, here's my y distance, it looks like in the same amount of time, I went more in y than I did in x. Does that make sense? So what we're going to do, we're on a section that's called related rates. And what we're going to do is take a look at equations and take the derivative of those equations, and we're going to use with respect to time, with respect to t. Does that make sense? All right, so that's where we're headed first. So here, can you guys see this okay? Maybe I should make this a little bit bigger. Is that a little bit better? And it says calculus is often described as the mathematics of change. Words that indicate change are increasing, decreasing, growing, shrinking, etc. So those are key words you want to look for. It means that something is changing. Change occurs over time. When quantities are changing in calculus, this is symbolically shown as the derivatives of that quantity with respect to time. So this right here is the rate of growth. And it's going to be dg over dt. Where do you suppose I got the g? Growth. And it's going to be 3 inches per year. So units are going to become a really important part. My mutual fund is shrinking by 4 cents per day. So this is going to be DMF, mutual fund, dt, is equal to what, Lillian?
4 cents over a day.
Okay, so could I do this? It's almost perfectly correct. There's a little bit, you have to make some type of adjustment because of the word shrinking. Negative. Or Madeline could have argued this. And both of those would be appropriate. Right? The radius of the circle is increasing by 4 feet per hour. Josh, I'm going to start with D, and what do you suppose I'm going to follow it with? R. Over? Pardon? DT. And that's going to equal 4 feet per hour. Natalie, the volume is decreasing. dV over dt equals what?
Negative 2 inches cubed.
Negative 2 inches cubed over seconds. Perfect. Does it make sense that it should be inches cubed, Natalie? Is that a measure of volume? Okay. What if it would have said area of a circle, which we're going to get to? What would you suppose the area of a circle would look like?
It would have to be squared.
Right, it'd have to be whatever unit is squared over the unit of time, correct? All right, good. In fact, we're bringing that up. Okay, so what we have here is we have a rectangle that's changing. Okay, that's the part you need to see. And for a brief moment, for an instant, So these rates are instantaneous rates. For an instant, for a moment, the dimensions are 10 by 6. Is it always 10 by 6? No. But it's a changing rectangle. Write the general formulas for perimeter, area, and rate of change in terms of L and W. So perimeter, P equals, and just to have, I'm going to draw a little rectangle so we have something to refer to. Here's my drawing of a rectangle. This is going to be L, and this is going to be W. So Allison, what's the perimeter of my beautiful shape? 2W plus 2L. Would you agree? Everybody agree? So Savannah, variable? Is P a variable? Okay, what if I told you W was 1 and L was 2? Could you compute the perimeter? Then in 1/10 of a second, it becomes 10 and 6. Did the perimeter change? So is it a variable? Okay, and that, in fact, this is the dependent variable, right? And it's dependent on what other two variables? W and L. And they're also changing. So when I write the change of the perimeter, this is going to become dP dt. That is the rate that the perimeter is changing. It can be positive, it could be negative. So what I'm going to do here is I'm going to take the derivative of W. And it's going to be 2. Remember, there's a 1 here, and 1 times 2 is 2, and then that goes to 0, correct? And then I got to multiply, since it's a variable, I got to have dW dt plus 2, because there's a 1 here. 1 times 2 is 2, and then that'll become a 1, times dl dt, because both the width and the length are changing at a certain rate. And those rates affect the rate of the change of the perimeter. So just like you took implicit differentiation and you took the derivative with respect to x, and you had dy over dx, and we had dx over dx, correct? And that became 1. Well, we're taking with respect to time. And so we have to know some rates. In the word problems we're going to see, they're going to give us rates. We have to have them. Area of a rectangle. Noah, in terms of L and width, and here's my beautiful rectangle. So what would be the area of that? Length times width. So when I have the change of area, I'm going to have dA dt. And now this is going to be the formula that tells us how to compute the rate of change of, or how fast, or what direction is the area, is the rate of the area increasing or decreasing? Musab, what's in between here? A little dot. What does that mean? Pardon? Multiply. So that means when I take the derivative, I got to do the product rule, okay? Which means I'm going to write down L and multiply it by what? Pardon?
1.
Well, I got to take the derivative of W, right? And it's 1 times what? Okay, so the question is, how do you take the derivative of W? There's a 1 out here, there's a 1 right here. 1 times 1 is 1. You get W to the 0 times what? dW over dt. So that's 1, this is 1. 1 times dW dt is dW dt. What's the next thing I'm going to follow it with? I got to put a operation in here. Plus what? Perfect. dl over dt. So, to compute the rate that the area is changing, I need 1, 2, 3, 4 variables. I need 4 variables. So I give you some information. It says the rectangle's length and width are increasing at a rate of 2 inches per second. That means dl dt is equal to 2 inches per second, and that dw dt is equal to 2 inches per second. And so here's my formula right here. The change of the perimeter, which is dp dt, is equal to 2 times 2 inches per second plus 2 times 2 inches per second which is going to give me what, Bryn? 8 inches per second? Does it make sense that the perimeter would be changing and my units would be inches per second? Because the perimeter is inches, correct? Right? Okay, the change in the area. So this is going to be dA dt. Now, it says that for a brief moment, my dimensions are 10 inches by 6 inches. So if you take a look here, I need L, don't I? What is L? Morgan. Based on my beautiful drawing. Okay, so I drew a rectangle, correct? Right? Why did you choose 10 besides that Noah told you 10?
It says in the thing.
Yeah, it says it's 10 inches and that's the longest side. So in my formula, which is right here, which Musab gave us, I'm going to have 10 inches times 2 inches per second plus, Morgan, I'm going to take another stab at it. What's W? 6 inches. So this is going to be over here, 6 inches times 2 inches per second. So, Sophia, what do I get when I do this computation?
32 inches per second.
I heard 32. I forgot to put my hearing aids in today, and I missed the last part. And be careful.
Squared,
What?
inches squared per second.
Inches squared per second. Now let's make sense. 10 inches times 2 inches is 20 inches squared per second. 12 inches squared per second, inches squared per second. Natalie, does it make sense that our area would be inches squared per second? Okay. Now, when you guys will have the wrong units, you're going to lose a lot of points. Does everybody see why? So right here now, Nick, it says rectangle's length is increasing as 3 inches per second. So what should I write here? dl dt is equal to what? Right? Is the length is increasing, so that's the rate that it's increasing? What? Yeah, what's rate is it? What length is increasing at what rate? 3 what? Perfect. dw dt, the change of the width, how's that different? Why? Because it's decreasing. So that means dp dt is equal to 2 times 3 inches per second. Ooh, yeah. Plus 2 times a negative 3 inches per second. And Ethan, what does that tell me?
Doesn't it come out to 0?
What?
Doesn't it come out to 0?
Comes out to 0. Which means what? There's no change in the what? Perimeter. Let's see. Here's 6, here's 10. For a brief moment, it was 6 by 10, correct? Where's that from?
Directly below us.
It's from that room right there.
Really? That might be Karsh.
Well, no, personal finance.
Okay? So in 1 second, do I have a rectangle that looks like this? I don't think so. Its perimeter is 32, right? But does my rectangle look like this 1 second later? No, it's different. How is it different? Well, it says in 1 second, the length increases, right, at a rate of 3 inches per second. So 1 second later, the length is what is it now? It's longer, correct? What is it? 13. What is it here? 3. Is that still a perimeter of 32? Right? All right, change in the area. dA dt is equal to 10 inches times dw dt, which Nick said was a negative 3 inches per second, plus 6 inches per second times the rate of increase, which was 3 inches per second. So as my size change, what happens to my area? Adam.
It's going to, like, decrease.
Decrease by what?
12 inches squared a second.
How do I write that?
I'm trying to figure out where you are.
You said everything right. What does it look like mathy? You said decreasing 12, right?
Yeah.
So that's a negative 12
Inches squared per second.
inches squared per second. All right. Next page. Number 3, the lengths of legs of a right triangle are changing. So I'm going to draw a right triangle. Josh, what do I mean by legs?
Um,
Is this a leg?
no, that's the doctors.
Can I call it H? Or you want me to call it C?
Yeah, no.
Call it C. I like C better than H anyway. Okay? Okay? So what would be the legs? The other two that connect at the 90-degree angle. What do you, I suppose you want to call those A and B? Okay. That seems to be popular. Okay? It says, so, area. Based on my beautiful drawing, what would area be? Josh. Addie's going to do the derivative, so you don't have to worry about that.
A to B divided by
Can I write it as 1/2 A times B and make it a coefficient?
2.
Okay. It might be easier for Addie. Okay. Addie, the change of the area. dA dt. I'm going to give you a little hint. I'm going to put a little time sign in there. Do you see it? Do you see it now? Time sign. So that means you got to invoke the product rule. So I got to have a plus sign in here somewhere, right? Where are you going to take the derivative of first? A. Okay. So what is the derivative of A? Remember, it has a 1 right there, correct? It's a variable that's changing. So what does it look like? I think I heard dA over something.
1/2
Did you say dt?
Yeah.
Okay. Right, because it's time, right? And you didn't do anything, so I got to have times b. What am I going to have on the other side?
1/2 A.
Very good. Times what?
PT over DT.
dB over dt. Becca, the hypotenuse. What's the hypotenuse?
C.
C. What does C equal? Is C related to A and B?
Yes.
How are they related?
The Pythagorean theorem.
Through the Pythagorean theorem, right? They both have Uncle Pythagoras to thank for that, right? Hence they're related. Okay? Give you a little example. Okay? My grandfather on my mother's side was John. And he came from a family of 9 kids. He's the oldest. And his parents came from Switzerland and settled in Wisconsin and then moved to southeastern Minnesota. His father dies after the birth of the 9th kid. And there wasn't a support system like there is now. There wasn't a welfare system or anything like that. And his mother has a nervous breakdown, and they put her into an asylum in Rochester. Okay? And that asylum was a mental institution that was in effect all the way through the 60s. And anyone that passed away there, they buried on that, at that institution, without a marked grave. My mother remembers going and visiting her grandmother at the institution. Her grandmother, my great-grandmother, never left. So what did they do with the 9 kids? Well, they were all not adopted. They were all sent to different families. My grandfather was, since he was the oldest, was not sent to a family. He was 14. He just had to live on his own. So what he did to survive is he worked at the bowling alley in Lewiston, Minnesota, which he pronounced Loyston, and set up bowling pins. And he got a penny a pin. And that's how he survived till World War I came along, and he was drafted into, then he joined the army, became a cook, came back with some money, bought some land, became a farmer, and the rest just happened. But what happened annually every year was there was an Ernst reunion, usually at my parents' place because they had a big lot. And people would come in, and I would have cousins, and they would be part of Emily's family. Somebody else would be part of Rudy's family. And that's how I got to know my cousins, was with these big family reunions. Okay? We were all related because we had been attached through this experience. Because they were separated, what they needed to do was make sure they maintained connections every year to do that. And we had some people that lived in Denver, some people that lived in California, some people that lived in Maine. But every year they would show up for this reunion. Okay? And all of them would grow older at different rates, dependent upon their health. And you can see it because my dad videotaped everything, but they were silent movies because he had an 8mm, which I think is more funny than the audio ones. So we're back to Becca. Okay? So the hypotenuse is related to A and B because of Uncle Pythagoras, correct? What's it look like?
The square root of,
Can I write a quantity to the 1/2 power?
yes,
It might be nicer, right? And what's inside that?
a squared plus b squared.
A squared plus B squared. Perfect. Ethan, you ready to take this derivative?
Not really, but yeah.
Okay. What's going to be on this left side?
DC
dc
over DT.
over dt. Perfect. Okay, Madeline? What do you think we should do on the other side? The icky side. Yeah. How did you know to do that? Did Ethan tell you? Yeah. And what other thing besides the exponent? I agree with the exponent. These things right here. Right? The what? No, this little thing right here. The parentheses, right? You have some type of mathematics being done inside parentheses, correct? But yeah, you want to look for this exponent and these parentheses. Okay? You know what this parentheses name is? The left parent. You know what this one is? The right parent. So I used to introduce myself, embarrass my kids. Hi, my name's Chuck. I'm the right parent. This is Julie. She's the left parent. And then my kids would walk away. Okay, so what does the chain rule look like? You're not going to have to do the whole thing because someone's going to finish it up for you. Okay? What's perfect? 1/2. Am I going to leave this stuff untouched inside here? Yes, you are. Great. And what does this become? Negative 1/2. Okay. What's the derivative of a squared? 2a times
2b.
plus 2b. Both of these have to be multiplied by something. A is a variable, right? So it needs to be multiplied by... Correct. dA over dt, which got really messy. Over here, this has got to be multiplied by what? dB over dt. So I'm going to make this nicer. Okay. So down here will be the square root. That's what Ethan wanted, so we'll put it in there. Or maybe Becca wanted that, sorry. Now, do you see where I can factor out a 2 here, folks? And that 2 and that 1/2 will simplify. Are we okay with that? And so up here I'm going to have a times dA dt plus b times dB dt. Lillian, I call that an awful formula. Okay. All right, so the short side. Lillian, which of these is shorter? Can you tell?
I'm guessing A, but.
Okay, let's make A the shorter one, okay? So the short side is increasing at 3 inches per second. So what should I write here? D, you said A?
Yeah.
dA dt is equal to,
3 inches over seconds.
okay? And dB dt, that's the longer side, is equal to,
5 inches over
and should they both be positive?
Yes.
Okay. And it says right here, the lengths are 30 and 40, right? And so this is going to be A. Why is it A? Because Lily said so. And B is going to be 40. So dA dt. Oh, the area. D capital of A dt is equal to 1/2 Noah times what? I'm using this thing right here.
Times
3 what?
inches
Times what? I got the half. You gave me 3 inches per second. We need B. What's B?
per.
We're up here.
Oh, 40.
40 inches, correct?
Yeah.
Plus a half. A is what? 30 inches times what?
5 inches per second.
Perfect, 5 inches per second. So half of 40 is 20. 20 times 3 is 60. So I got 60 inches squared per second. Noah, does that look correct?
Yeah.
Okay. Half of 30 is 15. 15 times 5 is 75 inches squared per second. Does that look correct?
Yeah.
Okay. And so I get 135 inches squared per second. Should I be inches squared per second? Because I don't want to get it all marked wrong because I put inches per second, right? Because I did way too much work. Does that look correct?
Yeah.
Alrighty. Change of the hypotenuse. Alex, dc dt equals, I got a square root down here. Ooh, it's a 30, 40, 50. So I know the square root of a squared plus b squared, it's c. C's got to be 50. I don't have any work to do. And it's 50 inches because that C's got to be inches. Wouldn't you agree with that? And up on top here, I have A, and A, according to Lily, was 30 inches times 5 inches per second plus B, which was 40 according to Lily, 40 inches, times, did I screw those up? This should be 3 and this should be 5. When you have terrible handwriting, to fix it in black pen is no problem, Josh, to fix, is it? It's like having an eraser when you use black pen, right? Okay. Does it look correct now?
Yeah.
So, Allison, 3 times 30. 90 what?
Inches squared over second.
90 inches squared over seconds. Plus 40 times 5.
200
200. Wow. 200 what?
inches squared per second.
Divided by 50 inches. Correct? So this is 290, right? It must be, okay, don't, let me figure it out. 290, right, is close to 300. 300 divided by 50 is 6. So I know it's not 6. 6 would be wrong, but it would be close. And so I am 10/50ths from there, which is, I think it's 5.8.
You're right.
Okay, 5.8. I've got inches squared divided by inches. Doesn't that give me inches per second? Should it be inches per second? Should it be inches per second? Is my circumference changing? Not circumference, hypotenuse. Should my hypotenuse be changing at inches per second? Is it a length? Yeah, it's a length. We doing okay? Alrighty. Now, this is what AP expects. They expect you know how to figure out the area of a square. They expect you know how to figure out the area of a rectangle. They expect you know how to figure out the area of a right triangle. Any triangle. They figure you should know how to figure out the area of a circle and the circumference of a circle. They do not expect you know how to figure out the area of a cylinder or volume of a cylinder. They will give you that, and so will I. A cone, I will give you that, and a sphere. They like spheres. They like cylinders. They like cones. All right? They will give you those formulas. But you got to know how to figure out the area of a triangle. They expect that you know the Pythagorean theorem. Okay? And of course, that you know trig. Okay? That's the one hiccup. All right. So the volume of a cylinder is pi r squared h. Now, this is the first thing so what's happening here is a right circular cylinder has changing dimensions. At this moment, the height is, I don't know why there's an n there. The height is 10 feet and the radius is 8 feet. You need to realize those are not constants. So it's like a balloon, that you're blowing up a balloon that makes a cylinder. I have a blowable hammer that I hit myself with. Okay? Part of the handle looks like a cylinder. You got the idea? All right, now, Nick, in this formula, how many variables are there?
1, 2,
Well, 1, 2, should we go 3 even?
sure.
Should I go 4? Should I go to 4?
Yeah.
Should I go to 5?
Yep.
I see V. I'll go 7. V, this segment, pi, R2, and H. One of those answers is correct. Is pi a variable? No. 2, the squaring term. Is it a variable? No. What about the equal sign?
No.
What about the volume?
No.
Is it a variable, the volume? It is, isn't it?
Yeah.
And it's dependent on what 2 things?
R.
So they're also variables.
Yeah.
Okay? That's the first thing I do is I go through and figure out my variables because I will need a dv/dt, I will need a dr/dt, and I'll need a dh/dt in this case. I always ask myself, what are my variables and what are my constants? So the change in the volume, dv/dt, equals. Natalie, what do you think?
You can use the product.
Yeah, why?
Because it's times in each other.
I will sleep tonight just because you said that. Thank you for that gift. Awesome. So do you want me to put the dot right here?
Sure.
You know, you ever read the book Treasure Island? Really? Do you know, Ethan, you have? You know what this means?
I saw the movie.
Do you know, you saw the movie? Did you see the Muppet version of Treasure Island? I enjoyed that a lot. I also read the book. So every time I put this time sign, I think of the black spot. Do you know what that means? No one knows? If you got a card with a black spot, it means you're going to die in the next 24 hours. There's a lot of death in this class. Okay, Adam, you ready?
Not really, but we'll go for
We got and she said product rule, and I know there's a plus sign with the product rule.
it. So, I'm thinking we're going to start with 5.
You're going to start with what?
We're going to start with, like, right after the equal sign, we're going to put the pi down.
Okay, what are you taking the derivative of first? R or H?
R.
Okay, R. So this 2 times this coefficient, right?
Yeah.
What do you get?
2 pi.
You know, there's a guy who got killed who used to do rap music.
Okay.
2 pi Shakur. I'm sure that was his name. You guys never heard that? He got like murdered or something, but he might be out there with Elvis. I'm not 100% sure. Okay?
Cuba.
Who?
They're in Cuba.
Yeah, where everybody else lives. Okay, so 2 pi what? Remember this 2 went to here, and then I got to subtract 1, right?
Yeah.
So it's, what am I going to have here?
dr over dt.
Well, I need to have what? The R didn't disappear.
Oh, the R is still there.
Yeah, because it's R to the first. Okay, the reason it disappears in the other ones is because it's R to the first, and when you subtract 1, it goes R to the 0. Is that okay?
Yeah.
And now I need that dr dt. And you didn't do anything with the H, correct? So I have now 1, 2, 3 variables on this side. Okay, what should I have over on this side? I got to take the derivative of what here now?
Would that be kind of like the same thing with 2 pi r with dh dt?
Yeah, so it's going to be 2 pi r squared, correct? Okay, because you've already done the 2 pi r squared. It just tags along, we can go, I'm done. Right? I'm not, oh yeah, I don't need the 2 here. The 2 is gone. It's just pi r squared, sorry. And now I'm going to take the derivative of this. there's a 1 here, correct?
Yeah.
So the variable h disappears, but the derivative of h is dh dt. You guys have now become piranha. As soon as somebody makes mistakes, it's like they attack. That's why no one wants to give an answer but me. Because what? You'll find out you're wrong? Wait till you're married. You're wrong every moment. It's just part of a relationship. It's like going shopping. Okay, you got to buy something, a can of tuna. How complicated can it be to buy a can of tuna? You know what I do? I buy the cheapest can of tuna. Not all cans of tuna are the same. It takes me forever to go shopping. Surface area. What's a cylinder look like? You guys ever make cylinders? Ethan, you ever make a cylinder? I made a cylinder when I was a little kid, probably 3rd grade. I was really into cylinders. This is how I would make my cylinder. I would take a piece of paper and I'd roll it up like this. And I'd get really tight. So it was like tubular. Okay? And then I would get a small piece of paper and I'd chew it up and get it really juicy. Now, I would never do this in school because I couldn't get in trouble in school, but at home, all the time. And I'd reach up and I'd make sure my dad, I had to sit by my dad for a lot of reasons. Okay? But I found out he had glaucoma. You know what one of the side effects of glaucoma is? You lose your peripheral vision. So a lot of times he couldn't see me. And I tested this out because I would move things for him, and like move his fork and stuff like that. He didn't even know I was doing it. So I leaned back one time. My mom got up to go to the refrigerator, and I put that I think it was like a pea at this time. And I hit my sister right between the eyes. Just like that. I didn't know I was going to be a math teacher. Okay. I got in trouble for that. Actually, that was the time she stuck her hair in my milk and made me drink it. So anyway, here's a cylinder for the people wondering. Okay. Okay. Now, right, this is the part that wraps around, right? Musabi, you know what you call this part of the cylinder? It's called the lateral area. Okay? These parts here are the ends. Okay? This is the lateral area. So when I look at the cylinder, this is the what to the cylinder, Musab? The height. Perfect. Now when I unfold it, it's a rectangle. Correct? What's this part of the cylinder? Yeah, it's the base, but it's this part right here, part of the end, correct? So what shape is that end? Circle. So what's that, this part of the circle? We'll find out tomorrow.